Sometimes the question arises, what is the connection between advanced mathematical formulas and real life? And here is an example of the connection between integration with this particular integral, the Fourier Transform integral, and sound processing. Fourier Transform integral makes the connection between t, which is time, and omega, which is frequency, which is represented in this piece of software over here called Goldwave, which is commercial software for processing sound and music. And this Fourier transform is often digitized into a discrete form for which many computer algorithms have been written. And here's an example. So to show you what this algorithm does, I want to open up a piece of music. And the time domain signal of this music is represented by these wiggles and squiggles that go up and down. So on the left, as we progress through time, it moves from left to right as the seconds pass by. On the right-hand side, we have the frequency representation, and every millisecond, that pattern is going to change as we play different notes through time. And as there are high notes and high sounds, such as the cowbells, you will see there will be spikes in the higher frequencies. And when you have the lower notes, such as the drums, those will be represented in the lower frequencies. So let me go ahead and play this. And as you can see over here, the marker moving through time. And again, the high cowbells having the higher spikes, and the lower drums having the lower frequency pattern. Next, I want to modify the sounds file by filtering out the lower frequencies. So to do this, I will go to Effect, and then there's a Filter command. And I'm going to select low pass, high pass. And if I want to filter out the lower frequencies, that means that I want to keep the higher frequencies. So this is actually going to be a high pass filter. So I want to keep the sounds whose frequencies are, in this case, higher than 1,000. So I'll hit OK. And as you notice, the height of the signal has greatly decreased because a good number of sounds have been filtered out. So now let's go ahead and play this. And you can see on the frequency pattern, the low frequencies are gone and the sound is really tinny. Starting back with the original file, we can do a similar thing to filter out the high frequencies and only keep the low frequencies. So again, we're going to go back to the effects and we will filter. And again, we're going to do low pass, high pass. But this time we want a low pass, as in allow the lower frequencies to pass or be kept. And we're going to get rid of the high frequencies. And so when we do this, you can see that the peaks, the sharp peaks have dulled a little bit. And when we go ahead and play the music, this is what happens. And again, you can see now the lower frequency sounds are kept on the frequency map, but the high frequencies have been eliminated. So this is one really practical application, and there's a lot of deep math that's buried in this piece of software.